Okay, we're going to deduce a few things from this dual model. One is that the general form is the from dual variable minus the dual variable has to be less than or equal to the cost going from to to. So this is interesting. Because it gives us a sense of what dual constraints have to be satisfied, and if it doesn't satisfy this, then we have an infeasibility. Problem is, how do we get the from and to variables? So the second thing that we want to observe is let's look at complementarity again, the complementarity condition. Complementarity tells us that if you remember, that the slack variable of primal constraint times the corresponding dual variable is equal to 0. So if you recall, if we have slack, if the slack is positive, then the shadow price, which is the corresponding dual variable, has to be 0. And if on the other hand, if the shadow price is non-zero, then the slack variable must be 0. That means the constraint must be tight. So we have this relationship. We can also extend this relationship and say that the slack variable of dual constraint times the corresponding primal variable has to be equal to 0. So if we have that the primal variable is positive, then the slack variable must be of the dual constraint must be 0. What this implies is that that for the primal basic feasible solution, so if the primal variable is basic, then that implies that the slack of corresponding dual constraint is going to be equal to 0. So what that means that if we have a particular variable, a primal variable is basic, so let's take an example here. Let's go back to our diagram. And we have that F1 W1 is basic. So if we go back to, so if F1 W1 is basic, then the dual constraint, the dual slack variable is 0, which means the dual constraint is tight, and that would imply then that F1 minus W1 will be equal to 900. And this is an interesting insight, and we'll carry on from there in the next video.